change that a squared into a 1. So I'm going to factor an a squared out. Is that okay? So let's see. I guess I can take the a out of the radical now. That's going to be a integrals 0 to a x squared square roots 1 minus x over a quantity squared dx. I didn't have to write x over a quantity squared, but it makes the substitution a little bit more obvious. What is the substitution? X over a equals sine theta, or x is a sine theta. So dx is a cosine theta d theta. Well, let's see, that's a integrals. Well, if x is 0, sine of what angle gives me a 0? Sine of 0 is 0. If I plug in x equal a, then we have a 1. The sine of what angle is 1?
Pi over 2.
So these limits of integration I'm far more comfortable giving you. I would expect you to be able to do that analysis. This one is a little bit beyond what I would expect on an exam. So x squared is a squared sine squared theta. Square roots 1 minus x over a squared is 1 minus sine squared theta. Dx is a cos theta d theta. What a mess. So where are we now?
You can change the 1 minus sine squared to that.
All right, a to the 4th integrals 0 to pi over 2. Supposed to be pi over 2. And let's see, he's right, that's a cosine, isn't it? Right, square root of cosine squared, so that's a cosine, sine squared, cosine squared. So, goodness gracious, I guess I have to use that power reducing formula, right? No? What do you mean no? Oh, show off. Beautiful and intelligent. Must be a nice way to go through life. What's it like? I can't imagine. I know dumb and ugly real well, though. All right, well, she's right. 0 to pi over 2. So sine squared cosine squared is, let me leave a little bit of room there. Sine theta cosine theta quantity squared. I'm not jumping right to the formula, she said. I mean, this is a natural thing you should have thought of doing when you see them both at the same power. And then her observation is going to kick in. She's saying, that's almost the double angle formula. If there were a 2 here, notice she just went ahead and put the 2 there, then it would be a double angle. However, can you really put that 2 in there? Not unless you put a 4 here. Now you can, right? 2 squared is 4. That's multiplication by 4. That's division by 4. We didn't really do anything, did we? We just changed the window dressing a little bit. So the purpose of this now, 1/4 a to the 4th, integrals 0 to pi over 2. The purpose is that this is now sine 2 theta. So I've got the sine of 2 theta, quantity squared, d theta. So we're not going to get away from the power reducing. It's just we didn't have to do it on both that, and then multiply those together, and probably have to do more power reducing. We're all ready to go on this monster problem. So 1/4 a to the 4th. And let's see, integral 0 to pi over 2. Go on. 1 minus cosine. We double the angle, whatever it is, so it's now a 4 theta, and it's over 2 d theta. Is that okay?
Mm-hmm.
So 1/8 a to the 4, and now we can integrate. What is the integral of theta? Of 1, theta. Very good, Larry, answer your own question. What's the integral of cosine 4 theta?
Negative, oh, sine.
It would be 1/4 sine 4 theta, so minus 1/4 sine 4 theta. We found the new limits of integration, so our job is okay at this point. We've already done the legwork back up there when we did the original substitution. So let's see, where are we on this? I hate these, but I hate math. 1/8, a to the 4. I'm going to plug in pi over 2, so I get pi over 2 minus 1/4. And when I plug in 0, everything's 0. So leave it like that. What a mess.
So for A, how do we get pi over 2?
Where did the pi over 2 come
Yeah.
from? You mean the limit of integration?
Yeah.
Well, so what I'm doing every time I do that, and I've been doing it in my head, and I'm glad you asked the question, because what we should do is go over to scratch paper. Actually, let's not use that. Let's use this. Since x is a sine theta. Oh, actually, I guess I should use the first one, huh? I'm substituting for x, not theta. So I've got x over a equals sine theta. And I know that x is equal to, for the upper limit, x is equal to a. So if I substitute that in, I've got a over a equals sine theta, so 1 is equal to the sine theta, and I know the angle that generates that.
Right.
Pi over 2.